All right, in this video, I'm going to do a little bit of the unit circle review. So what you're seeing right now is a filled in unit circle. Remember, you've got all of your degree measurements, the radians that they match up to. So 60 degrees is pi over 3 radians. Okay, so these are equivalencies. And then all of these ordered pairs that are all around the unit circle, they represent two very specific pieces of information. And that is the cosine of your angle compared to the sine of your angle. So it's cosine sine. All right. And the other thing that you need to know, because there's no, right, we've got cosine, we've got sine, we don't have a comma tangent here, right? So let's talk about tangent for these problems. One of the definitions for tangent is tangent of an angle is equal to sine of that angle divided by cosine of that angle. So tangent is equal to sine divided by cosine. So we are going to use this fabulous unit circle information, and we're going to do two things with it. We're going to remind ourselves how to evaluate, and then we're going to remind ourselves how to solve. So I'm going to be working back and forth up and down here. So question number 1, part A. I want to find the sine of 240 degrees. So I'm going to go to 240 degrees, which is right here. I'm going to go to the ordered pair here, and I just wrote it down, but I'll write it down again. That ordered pair is cosine sine. So if I want sine, which I do, I want the y value of the ordered pair. So that's going to be negative root 3 over 2. So negative root 3 over 2, and sine of 240 is done. All right, let's talk cosine of 315. I can't read my own writing there. So cosine of 315. So I'm going to go to 315, find the ordered pair. And just like the ordered pair over here, cosine is the x value. It's the first value. So 315 has a cosine value of root 2 over 2. So root 2 over 2 right there. All right, we've got the sine of 30 degrees. So I'm going to go up to 30 degrees right here. Sine is the y value. So sine of 30 is 1/2. All right. Let's see, cosine of 135. So I'm going to go up to 135. Here's 135. And cosine is the x value. So it's the first value right here. So negative root 2 over 2. So cosine 135, negative, whoops, I think I said root 2 over 2. I'm going to double check that one because I feel like my brain just said, yep, there we go. I did get it right. All right. Now these last two, part E and part F, we've got to deal with tangent. So the tangent of 60, I'm going to go up to my 60 degree information. All right, so that's right here, and I'm going to create a fraction out of it. So I'm going to take the sine piece, which is root 3 over 2, divided by the cosine piece, which is 1/2. It's going to make a big old fraction for us. All right, so what did I say there? Root 3 over 2 divided by 1/2. Okay, so root 3 over 2 divided by 1/2. Don't like the complex fraction, so we are going to get rid of the complex fraction. We're going to multiply by the reciprocal of 1/2. So times by 2 over 1, times by 2 over 1. So in the denominator here, that whole thing cancels out. That's why we use the reciprocal. And then in the numerator, conveniently, this 2 right here can divide out that 2 right there. So 2 and 2 are gone, and what's left is a root 3 over 1, which is lovely. You don't really need the denominator of 1, so we just write down root 3 there. All right, one more in this. What were the directions there? Oh, just use a unit circle, fine. So evaluate. So tangent of 330. All right, so tangent, again, we're going to do the fraction, but 330 here, we're going to take this ordered pair, and tangent is your sine value divided by your cosine value. So that's going to be negative 1/2. So negative 1/2 divided by root 3 over 2. Now, just like in the last problem, we're going to go ahead and multiply by the reciprocal. So 2 over root 3 times 2 over root 3. So those divide out, those divide out. All of that's gone, so no more complex fraction for us. And then in the numerator, I'm saying numerator is in the whole fraction up here. We have a 2 here and a 2 here that can absolutely divide each other out. And what I have now is -1 over root 3. Not a huge fan of that because of the root 3 in the denominator. I want to rationalize this. So we're going to multiply by root 3 top and bottom. And this ends up being -√3 over. Now, in the denominator, you can do one of two things. You can just multiply and say, oh, root 3 times root 3 is the square root of 9. And the square root of 9 is 3. Or if you look at this as root 3 times root 3, which is root 3 squared, the square and the square root cancel, again, leaving behind 3. The way your brain picks it up, work with it. Both of them are mathematically accurate. So that is, let's kind of pinch that in, A through F on question number 1. So that's evaluating, finding those specific values using the unit circle. All right, next set of questions we are going to be solving using the unit circle. So in these problems, right, this question number 1, I gave you the angle, right? Each one of these I'm giving you an angle measure and you found the value for the unit circle. Well, we're kind of going to do reverse here. I'm giving you the value. I want to know what angle has that value, in this case for sine. Okay, so at what radian measures is sine equal to a positive root 3 over 2? So I'm going to go up to the unit circle. I'm going to look for the sine component. So that's going to be the y value of your ordered pair. And I want it to be a positive root 3 over 2. So let's see what we got here. So in the y values, let's see. Hey, look, that's a positive root 3 over 2 for sine. So that's going to be pi over 3. And let's see if I have found any others. Oh, look, right here. So this is root 3 over 2, and that's at 2 pi over 3. If I keep going, these are all negative sine values. These are all negative sine values. So we're going to have pi over 3 and 2 pi over 3 as our answers for question number 2, part A. So pi over 3 and 2 pi over. That looks horrible. Let's try that again. Over 3. All right. So next one, cosine, same thing, but I want to look for a -1/2. So cosine are my x values. So let's go up to the unit circle. Let's find some negative x values. Well, these are all positive. All right, right here I've got a negative x value at 2 pi over 3. So that's going to be -1/2 here. So that's at 2 pi over 3 radians. And then let's see what else. Ooh, this one right here. That's 4 pi over 3 when cosine is -1/2. So 2 pi over 3 and 4 pi over 3. So 2 pi over 3, 4 pi over 3. A little comma to separate those answers for theta there. Now, part C, we have to do one step first before we can actually go look for the unit circle. And what basically we need to get rid of that squared. So we're going to take the square root of both sides. So this is going to be cosine of theta is equal to, now immediately I'm going to put the plus minus in because I need to have both the positive and negative answers. And when you have a fraction under a root, you can break this up into the root of the numerator, so root 3. Cool, I don't know what that is. And the root of the denominator, square root of 4, I do know what that is. That's root 2. So what I'm going to be looking for here is all of the places through the unit circle where cosine has a value of either positive root 3 over 2 or negative root 3 over 2. I want all of them, okay? Now, cosine are x values, so let's slide on up. So what did I say, root 3 over 2? Yes, I did. All right. So let's see what we got here. Root 3 over 2 right here, pi over 6. And these are the x values again, because we're looking at cosine. Let's see, negative root 3 over 2 right here. That's okay. We wanted negatives as well. That's 5 pi over 6. Here's another negative root 3 over 2, so 7 pi over 6. And one more positive root 3 over 2 for 11 pi over 6. So pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6 all have either a positive root 3 over 2 or a negative root 3 over 2. So I want all of those answers. So sliding down here. All right, what did I say? Pi over 6, 5 pi over 6, 7 pi over 6. Those 6s are looking sad. All right, better. And 11 pi over 6. All 4 of them are valid answers. All right, last one. We've got the sine of theta is equal to a negative root 2 over 2. So let's go search the unit circle for any y values that are negative root 2 over 2 for sine. So all of these y values up here are positive. All of these y values are positive. So we're going to be looking down at the bottom part here. All right, here is a negative root 2 over 2 for sine, right? Sine are your y values. And that's at 5 pi over 4. And I have another one right here, right? Again, that's the y value for sine, and that's at 7 pi over 4. So 5 pi over 4 and 7 pi over 4. Whoops. Actually, right before it. There we go. All right, so this is a little bit of a review for how you work with the unit circle. Remember, you do not have to memorize the unit circle. You just have to be able to use it. So if I give you this unit circle, you need to remember again, each one of these ordered pairs is cosine sine. It's alphabetical order if you can remember that. And then one of the definitions for tangent is that tangent is equal to sine divided by cosine. All right, I hope this has helped. And of course, if you have any questions or concerns, let me know. I'll see you in the next one.